Okay, so uh, just consider that the Lagrangian function is a function. Now Hamiltonian proposed a new variable, and to derive that variable, the procedure that was adopted is just find out the partial derivative of L with respect to Qi dot, and whatever that term will be, just say that this is Pi. Okay, so in all n variables are defined. P1 is curly L by curly Q1 dot, P2 is curly L by curly Q2 dot, and so on. Pn is curly L by curly Qn dot. Okay, now we are just going to find out a relation between Qi dots and Pi. And when you studied in your second semester the topic of Jacobians, at that time you studied that there will be a functional relation between these variables if their Jacobian should be non-zero. Jacobian is nothing but the partial derivative of those coordinates with respect to the those functions with respect to the corresponding all possible components. Okay, that condition here also, because we are going to find out a relation between Pi's and Qi dots. So the partial derivative of Pi's with respect to Qi dots should be non-zero, or we can say that second partial derivative of L with respect to Qi dot Qj dot should be non-zero. It is stated in equation number 3. The determinant of curly 2L by curly Qi dot curly Qk dot should be non-zero, and this term is known as the Hessian of the function L. When we are dealing with first partial derivatives, then it is termed as Jacobian, and when we are dealing with the second order partial derivatives, then it is known as the Hessian. Okay, so Lagrange was having some components T, Qi, Qi dots. Hamilton proposed the new one that the quantities will be T, Qi and Pi, where Pi is termed as the generalized momenta, and Pi should be the partial derivative of L with respect to Qi dot. Okay, and the most important condition is that determinant of curly 2L by curly Qi dot and Qk dot should be non-zero. Okay, after that the Hamilton function is defined, and then Hamilton canonical equations are stated with terms. So I am not discussing these. When we will derive these, all these terms will be discussed. Okay, so today we are going to discuss the very first theorem, that is known as the Duncan's theorem, and it states that if a function is given, say x, which is of the components x1, x2, xn, and Hessian of this is non-zero, means determinant of curly 2x by curly xi curly xj should be non-zero. Then we defined a new variable with the help that yi should be curly x by curly xi. And now, up to now, everything is given. These are the hypotheses. A function is given of which the Hessian is non-zero. A functional relation is given that partial derivative of x with respect to xi should be yi. Now we are to obtain a function y that will be a function of y1, y2, yn, and partial derivative of that new function with respect to yi should be xi. Okay, after there is a second part of this also that we will discuss when we will prove. I am just going with the first part, that x is given, partial derivative of x with respect to xi is yi, and we are going to find out a new function y such that the partial derivative of y with respect to yi will be xi. Okay, so for this, just assume that the generating function y of the inverse transformations is this relation. It is given. Now let's define y. That y will be what is this? Old variable into new variable means it is x1 x. Now with one look we can say that this y is a function of xi, yi and x. It is also a function of x1, x2, xn. So this y is a function of x1, x2, xn, y1, y2, yn. But we need that this function should be of variables express this x1, x2, xn in terms of y1, y2, because in Jacobian we studied it. That if this is non-zero, then xn can be expressed in terms of x1, it will be a function of y1, y2, yn, x2, it will be a function of y1, y2, yn, and xn, it will be a function of y1, y2, yn. Okay, so xi will be a function of y1, y2, yn, say it is fy. And now replace this xi from equation number 4 into equation number 2. Then y will be a function of y1, y2, yn only. Because xi is replaced in the first summation, and in x also, xi is x1, x2, xn are replaced by these functions. So in all the expression on right hand side is in terms of y1, y2, yn only. And hence y is a function of y1, y2, yn. So the function is obtained. Now we are to find out that partial derivative of y with respect to yi should be xi. Okay, for that just find out the partial derivative yi of summation k from 1 to n xk yk minus capital X. And now just listen. First of all, in this summation there are two terms, so u into v method will be applied. First thing, partial derivative of xk with respect to yi into yk, okay, plus second time the first term of this summation is x1 y1 and partial derivative of y1 with respect to yi 0. Second term is x2 y2, partial derivative of y2 with respect to yi is 0. Ith term is xi yi and partial derivative of yi with respect to yi, it is 1. So xi is remaining. Minus, okay, x is a function of xi and xi is a function of yi. So it will be summation k from 1 to n partial derivative of x with respect to xk into partial derivative of xk with respect to yi. This yk is not there, the last yk in equation number 5. The chain rule is applied. X partial derivative of x with respect to xk and partial derivative of xk with respect to yi. Now it was given that xi is equal to curly y by curly yi. Oh sorry, yi is curly x by curly yi. So replace that yk with respect to that term. Means replace yk in equation number 1. It is given yk will be curly x by curly xk. Okay, replace this in equation number 5. What is yk? Curly x by curly xk. And now this summation and the last summation in equation number 5 are similar. So these will be cancelled and only term that is remaining is xi. So xi is equal to curly y by curly yi. And with this the first part is proved. Now let's move towards the second part. In the second part, it states that although x is a function of x1, x2, xn, but Along with this, if X contains some parameters, alpha 1, alpha 2, alpha m, means now X is a function of x1, x2, xn, and some parameters alpha 1, alpha 2, alpha m, then the obtained function y will also contain these parameters. Means y will be a function of y1, y2, yn, and alpha 1, alpha 2. X to alpha j. Okay, means that with respect to each other. Now, if when we for xi as a function of y1 expression, so y1 alpha 2, and now replacing all these xi's into the expression for y in equation number 2, then y will also contain alpha 1, alpha 2, alpha m. Okay, so y will be a function of y1, y2, yn, alpha 1, alpha 2, alpha m. Further, finding the partial derivative of y with respect to alpha j, it will be partial derivative of with respect to alpha j of summation I from 1 to n xi yi minus x. Okay, now xi, it's a function of alpha 1, alpha 2, alpha n as stated in equation number 7. Xi is a function of alpha 1, alpha 2, alpha m. So in this summation, it will be summation I from 1 to n partial derivative of xi with respect to alpha j into yi as it is, plus second time summation I from 1 to n xi as it is, but yi, it's a variable, so its partial derivative with respect to alpha j will be 0. Now x is a function of xi's and alpha j's. So and xi is a function of alpha j. So what will happen? First of all, partial derivative of x with respect to x1 will be there, and then partial derivative of x1 with respect to alpha j. Then x2 alpha j, x3 alpha j, xn alpha j. So the first summation is there. Summation I from 1 to n curly x by curly xi into curly xi by alpha j. And then partial derivative of x with respect to alpha j will be there, because x is a function of alpha 1, alpha 2, alpha m also. Okay, and now replacing yi with the given condition that it is curly x by curly xi. So the first two summations are similar, will be cancelled, and the only term that is remaining is minus curly x by curly alpha j. Hence, the Dunkin's theorem is obtained. Okay, after that, so Dunkin's theorem is obtained. Now let's try to find out the Hamilton canonical equations. The most important thing in Dunkin's theorem is, I'm going again to the statement. Yes, a function x was given, that was a function of x1, x2, xn, alpha 1, alpha 2, alpha n. Also it is given that yi is equal to curly x by curly xi. Yi was the new variable. Then we obtained that xi is curly y by curly yi. Old variable is equal to partial derivative of new function with respect to new variable. And the parameters are remained as it is. And those terms which are remaining as it is, the partial derivative of both the functions with respect to those variables are negative of each other. Now, L, the Lagrangian function, is a function of t, qi and qi dots. The Hamiltonian function, it will be a function of t, qi and pi. Just try to compare. We are having the Lagrangian function L, in which the variables are t, qi and qi dots. We are to find out function h, that will be a function of t, qi and pi. So we are having L, we are to find h. So in Duncan's theorem, the role of x will be played by L and the role of y will be played by h. Means y will be replaced by h. Also, t and qi are common in both the functions. So these alpha 1, alpha 2, alpha m will be replaced by t and qi. And pi was defined like curly L by curly qi dot. So instead of xi, we will have pi. Sorry. Instead of yi, we will have pi. And in place of xi, we will have qi dot. Okay. So x will be replaced by L, y will be replaced by h, xi will be replaced by qi dot, yi will be replaced by pi, alpha j will be replaced by qj, and t also, but we are skipping t. So let's try to find out the Lagrangian equation, Hamilton canonical equations. It is stated here that x1, x2, xn will be replaced by q1, q2, qn. Alpha 1, alpha 2, alpha m will be replaced by q1, q2, qn and t. y1, y2, yn will be replaced by p1, p2, pn. And the y, it was minus summation I from 1 to n xi yi minus x. Now instead of xi, we are having qi dots. Instead of yi, we are having pi. And instead of x, we are having L. And instead of y, we are having h. So what we will have, h is equal to summation I from 1 to n pi qi dot minus L. And what is pi? It is curly L by curly qi dot. Now just use the Duncan theorem, which states that the old variable will be partial derivative of new function with respect to new variable. So qi dot, it will be curly h by curly pi. What is qi dot? It is dqi by dt. So dqi by dt is equal to curly h by curly pi. And also curly L by curly qi, it will be minus curly h by curly qi. And with t, it is same. But we don't need that, so I am skipping that. Also, the Lagrange equation of motion are d by dt of curly L by curly qi dot minus curly L by curly qi is equal to 0. Replace curly L by curly qi dot and curly L by curly qi from equation number 5. Curly L by curly qi will be replaced by minus curly h by curly qi. And from equation number 3, curly L by curly qi dot is pi. So it is dpi by dt minus, and then on right hand side it is minus curly L by curly qi. So we are having the equations qi dot is equal to curly h by curly pi, and dpi by dt is minus curly h by curly qi. Means dqi by dt is equal to curly h by curly pi, and dpi by dt is minus curly h by curly qi. And these are known as the Hamilton canonical equations. Okay, there is one more article, that is the Roth equations. I think we should discuss it tomorrow or in the next lecture. Okay, however, it is also based on the Duncan's theorem. You will have a look on this, and I would like to discuss it in the next lecture. Okay. Any problem or anything else from your side?